Welcome to video number 7 in Microsoft 365 Excel, the complete story. And in this video, we got to talk about logical tests and conditional calculations amongst the most important things in Excel because we use them everywhere. SUMIFS functions, pivot tables, filter function, Power Query, if function, and or functions, and much more. You are not going to believe all the topics in this amazing video. 24 amazing topics. We're going to have some theory at the beginning and then all sorts of amazing examples of logical tests and conditional calculations. Not only that, but there's a lot of worksheets in this workbook. So for this topic table of contents, I created these hyperlinks that'll jump to each sheet for a particular topic. Now we're going to start off by going to the sheet Start. Now, a logical test is an expression, a formula, like in this column, a calculation, like in a pivot table, or a filter, using these drop downs, that evaluates to one of only two possible values, true or false. Now, sometimes when you run a logical test, you see the true and false. Other times, you just get a conditional calculation, like the total sales for the condition apples. Now, these two possible outcomes, true and false, are called Boolean values, named after the 19th century mathematician George Boole. A logical test or Boolean test can have one or more requirements called conditions or criteria. Here, for this calculation, true or false, looking at the record, the conditions are product has to equal bananas, and the sales have to be greater than or equal to 1,000. Each one of these is a condition. Together, they're criteria. Now, anytime you make a calculation or perform data analysis, here's a calculation that's part of data analysis. And you do that with one or more condition or criteria, you're running a logical test. So lots of us do filtering, pivot tables, but we may never think that behind the scenes there is a logical test. Now, logical test in the Excel worksheet with worksheet formulas and in Power Pivot and Power BI with DAX. Those logical tests are not case sensitive. Example, lowercase b equals uppercase B. If I change this, and down here, we'll see how to create these later, it's using that as an input, and it's checking it against the product for this record. If I change this to lowercase b, I still get a true. That's because lowercase b is equal to uppercase B. Now, as we saw many times earlier in the class, Power Query is case sensitive. Lowercase b is not equal to uppercase B. Control Z. Now, with logical formulas in the worksheet or DAX, any non-zero number equals true, 0 equals false. Yeah, that seems strange that -1, 1, 10 are all considered true by Excel. But the reason they programmed it this way is to allow more flexibility when you're creating logical formulas. And we'll see some great examples where we take advantage of this fact. However, in Power Query, because of data types, this trick doesn't work. Now, logical tests can involve comparative operators, 6 different comparative operators, and we'll get to see all of these in our examples. Logical functions like COUNTIFS, isNumber, and filter in the Excel worksheet. And in DAX and in the worksheet, we have functions like and, or, and if. There are many other logical functions also. Built-in features like conditional formatting, data validation, filtering, or pivot tables, they all do logical tests also. And of course, in Power Query, features, operators, and functions can all do logical tests. Now, over on the sheet L, I have some awesome notes all about logical tests, describing the basics and the different types. Now, here are the 8 most common logical tests. And I want to go back over to Start and look at these 6 to start off this video. Now, we're going to look at those 6 logical tests using the filter feature and the pivot table. And in fact, we've already talked about most of these logical tests in the context of data analysis back in video number 4. So we're going to remind ourselves here, and then the rest of the video will be about worksheet formulas and some Power Query. Now, a single condition logical test, that's when there's just one condition involved. In a pivot table, the sum of sales is only for the single condition apples. So the pivot table feature went through and said, are you apples? True. So it used this number. Are you apples? False. So it didn't use this number. And it continued the pattern all the way down, finding only apples and then adding a single condition to get a conditional calculation. Now let's look at filter using a single condition. If I want to filter all the records and show only records where customer equals Thriftway, that's a single condition. I click Filter, unselect all, check Thriftway. But before I click OK, it's not going to show us what it's doing, but it asks the question, is Foodtown equal to Thriftway? False. Is Whole Foods equal to Thriftway? False. It got false, 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 and there's a true. It continued all the way down, and when I click OK, it shows me only the records where customer is equal to Thriftway. Now to unfilter, you can click the filter, clear filter, or we can use Control-Z. Now the next type of logical test we want to look at is a contains logical test. And a contains logical test can be done as a single logical test or with two or more conditions. All we want to ask is, please show me the customer when the name contains WAY. So this doesn't contain WAY anywhere, so false, false. There's a true because the last three letters have way, false, true, and so on. Now we'll do contains criteria in worksheet formulas, and you'll see it's a little bit more complicated than it is with a filter. I come up, and filter always knows the data type in the column, so it offers up some data type specific filters. Text filters, and there's a bunch of text logical tests, and the one we want is contains. Now one thing about filter that's different than worksheet formulas. When I type way as the condition, I'm hard coding this into the dialog box. I am not allowed with the filter feature to connect it to a cell. Of course, when you connect something to a cell, then it's easy to change and have whatever you're working on update. Later, we'll see that the filter function can do that. But there it is, contains way, click OK, Safeway, Safeway, Thriftway, all the way down. Control-Z. Now the next type of logical test is a not logical test. That means not equal to. So if I ask the question of the customer column, is the customer not equal to Foodtown? Well, for the first record, is Foodtown not Foodtown? That's false. And it's false because Foodtown is Foodtown. Is Whole Foods not Foodtown? True. Safeway not Foodtown? True. If we use our filter, we come up to text filters, and there it is, does not equal. In the dialog box, we'll type Foodtown and enter. And sure enough, there's all the records where the customer is not Foodtown. Control-Z. So we looked at three different types of logical tests using a single condition. Now let's look at logical tests where we have two or more conditions. Now when you have two or more conditions, the two main types of logical test are the AND logical test and the OR logical test. Now before even defining these, we already know exactly what these two logical tests mean. If I say to my kid, you got to do your homework and take out the garbage, then you can have dessert. It's only when he does both that he gets the dessert. For an OR logical test, if I say, hey, you got to do your homework or take out the garbage, you only got to do one. Guess what? You could take out the garbage and not do your homework. You could do your homework and not take out the garbage, and you could do both. And what this means is for an AND logical test, all individual tests must evaluate to true. If you only have two tests, the only possibilities are false, false. Well, that's false. True, false. Even though you got one true, they're not all true. So that comes out false. False, true, well, that's false. The only time you're going to get a true, from the AND logical test is when you get 2 trues. On the other hand, an OR logical test requires 1 or more tests to evaluate to true. So for 2 tests, all the possibilities are false, false. Well, there isn't even 1 true, so of course that one is false. True, false. Well, in this case, we have 1 true. So the OR logical test delivers a true. False, true. Well, there's at least 1 true, so the result is true. If we get true and true, well, that's 2 trues. That's more than 1, so the OR logical test delivers a true. Now for and OR logical tests, you can definitely have more than 2 logical tests. And we'll see examples coming up. Now let's look at some examples of and logical tests. And we'll start with our pivot table first. Right now, this is a pivot table, and these are calculations that are based on a single condition. So right here, this is the total sales for bananas. But if I come over to the slicer and add a second condition, I want to add, but only when the product is bananas and the customer is Safeway. Now this calculation, adding, is based on 1, 2 conditions. If we look at our data set, is Foodtown equal to Safeway? False. Apples equal to bananas? False. How about Whole Foods equal to Safeway? False. Bananas equal to bananas? That's true. But it's only when we get Safeway equals Safeway and banana equals banana that we can use the number over in the pivot table calculation. As we go down, here's another record. Here's another matching record. As another example, anytime you use 2 columns and you use the filter drop-downs, you're doing an AND logical test. So let's say customer equals Safeway, and from the sales column, the sales amount, and notice, this is a data type filter specific to numbers. And look at this. There's a bunch of filters, or these are all logical tests. And we're going to say greater than or equal to. And when I type 1,000, all sales that are equal to 1,000 or greater will be included. When I click OK, I filter this data set based on an AND logical test where the customer equals Safeway and sales are greater than or equal to 1,000. Control Z, Z. Now let's do an AND logical test on all 3 columns. We'll say Safeway, and we're going to uncheck and say bananas. Click OK. And then sales, for this one, we're going to use a number filter and say less than. And when I say 750, 750 would not be included if it were in this column. Click OK. And it looks like there's just 1 record that meets our AND logical test. Customer equals Safeway and product equals bananas. And the sales are less than 750 bucks. Control Z, Z, Z. Now you can also run an AND logical test with the AND function. We'll see how to use this later. You can have up to 255 logical tests. But I've never seen a formula with that many logical tests. However many you put in, if they all come out true, AND delivers a true. So we're asking the question, is the product for this row equal to bananas? And are the sales for this row greater than or equal to 1,000? It's only here for this record that we get a true. All right, now let's consider an OR logical test. Now, one of the most important things to understand about an OR logical test is whether or not you're asking the question of a single column or 2 columns. Now, if you ask an OR logical test of a single column, there are only 3 possible outcomes. Whereas if you ask an OR logical test of 2 columns, there are 4 possible outcomes. Now let's see exactly what that means. If we ask the question, is the customer for the record equal to Foodtown or Whole Foods? For every record in the data set, we're going to have to ask 2 questions of the customer. So for this first record, we ask, is Foodtown equal to Foodtown? Well, that's true. Is Foodtown equal to Whole Foods? That's false. There's at least 1 true, so the result is true. That record is included. Is Whole Foods equal to Foodtown? False. Is Whole Foods equal to Whole Foods? True. So here we get a false true. This record is included. Is Safeway equal to Foodtown? False. Is Safeway equal to Whole Foods? False. So that record is not included. That's it. Those are the only three possibilities. And the reason why is Foodtown cannot simultaneously both be Foodtown and Whole Foods. So when you're running an OR logical test on a single column, you can never get true, true. Now, that's all the theory, and we'll actually use that when we're doing worksheet formulas. But when we're filtering, we just check from our unique list, Foodtown, Whole Foods, click OK. And we have the records that match that OR logical test on a single column. Now, Control Z, whereas a single column, you can never get two trues. When you do an OR logical test across two columns, you can definitely get two trues. If we run the OR logical test, is product equal to banana, or are sales greater than or equal to 1,000? Well, that's a false. This is a true, so that one's included. True, false, that's included. But look at this. True, true. Well, that record's included too. It's not until we get false, false, that's not going to be included. Now, unfortunately, when you do an OR logical test across two columns, you can't use these filter drop-downs. If you want to use the filter feature, you actually have to add an extra column like this. This will not work because it's an AND logical test. If I change this label that we learned how to create last video, F2, I'm going to cheat here. See, it says AND. If I change this to OR, sure enough, there is an OR logical test function. We have two logical tests. Control Enter. Double click and send it down. Also, we do not have a filter drop down here. And this is not an Excel table, so I'm going to click, go up to Data, turn this off. And now that this is attached, when I Data Filter, it'll be included. Then we can use the drop down and select our OR logical test true. Click OK. Now you can see that two columns for an OR logical test is a little bit more complicated. But it does happen, so we have to know how to do it. Now Control Z. Now one last OR logical test, and it involves a single column. And this OR logical test is something that Excel users all over the world do all the time. But they probably don't know it's an OR logical test. This is a slicer. It's in the filter area of the pivot table. If I hold Control and select two items, we should immediately recognize that, hey, we have two conditions on a single column. That means we're doing an OR logical test. However, we're actually doing what's called a complex filter because we're mixing OR and AND logical tests together. Now, how we say this in English actually disguises the structure of the logical test. Because someone would probably say, I need you to add all the sales from this column for bananas from Safeway and Thriftway. But these two conditions do not have an and between them. A more correct way to say it is I need you to add all the sales for bananas from Safeway or Thriftway. Still further, a better description that describes exactly how we have to build this logical test into formulas is please get all the sales for bananas and Safeway or bananas and Thriftway. Now let's apply that logical test to this second record. We ask, is bananas equal to bananas? True. And is Whole Foods equal to Safeway? False. So that and logical test is false. Then we say, or is bananas equal to bananas? True. And is Whole Foods equal to Thriftway? False. We get a true and false, which of course in an and logical test is false. And there you go. That or has two falses, so the record is not included. Now if we look at this third record, we can see that one of the and logical tests, bananas equal bananas, Safeway equals Safeway, well, that's two trues, which in an and logical test results in a true. And since it's inside of an or, all we need is one true to keep the record. So that number is used in the calculation. Now, the lucky thing is when we're doing a complex filter like this, if we're using a slicer and a pivot table, we don't have to think of the actual logical test. We just have to build this solution. But later, when we're building formulas, especially the amazing filter function, we'll have to think of that exact logic. All right, so that's the basics of logical tests. And be sure on this sheet L to look through this. It's in the PDF notes also. Now we want to go over and talk about comparative operators on the sheet CO. Now here's a list of our 6 comparative operators and common ways that they're expressed in English. Now when you're learning comparative operators for the first time, sometimes how people express that comparative operator is tricky. If they say greater than or equal to, well, then that's easy. But what if they say at least? If the hurdle is 2,000, they're going to say at least 2,000. What that means is this is the minimum number. But if that's the minimum, anything above is acceptable. So you can look through this. Also down here, how we use these comparative operators are different inside of functions like SUMIFS and COUNTIFS as compared to a direct calculation like we see in the filter function. And we'll see examples of these coming up. These are notes, and they're over in the PDF notes. If we go over to comparative operator example, I set up a column of 2 items. You're going to practice your comparative operators, building your formula here. Now, when you do this, you'll get some surprises. The answers are on this sheet. Also, really important with logical formulas. Sometimes we need to check whether an item is a certain data type or a certain item. So you can use is number on this cell, and it'll say true because it's a number. But down here, that looks like a number, but underneath is a formula. So when you use is formula and point to that cell, it'll say true. So you can practice these, and we actually have some cool examples with is number and is blank. Here's the answers. Then over on B answer for Boolean, we already saw how to use various math operators to convert a text number to a number. But you can also use these same math operators that don't change the value of something on Boolean values. So if we take a true and add 0, it's converted to 1. Take a false and add 0, it's 0. And converting trues and falses to 1s and 0s is sometimes really important in formulas. So you get to practice this over here. All right, we want to go to the sheet SC for single condition. Now our goal with this data set is to calculate the average GPA by major with a pivot table, worksheet formulas, and Power Query. Now we'll start with the pivot table because, of course, that's the easiest. So I click in a single cell, and we're going to use our keyboard, Alt-NVT. There's the name of the Excel table. We're going to put it on existing. Let's try B19. Click OK. Major down to rows, and instantly we get a sorted unique list. GPA down to values. It defaults to sum because it's a number. Right click. Summarize values by, and we want average. Expand the column, and bam, we're done. Each one of these average calculations have a single condition. So for the single condition business, it looks like we took the first and the 5th number. And boy, those are some low scores for business. But sure enough, when you average it, that's the average. Now let's try worksheet formulas. And since we're in Microsoft 365, we have some amazing functions to do this. Now I do need a unique list, so I type equals unique. We simply highlight the major column, and when I hit enter, there's our unique list. Now this is a spilled array, so we got to go back to the top cell and F2. We want it sorted, so we use another amazing dynamic spilled array function, sort. Close parentheses and enter. And remember, with these dynamic spilled arrays, they're grayed out because they're really not there. That formula lives in the top cell and spills all the results below. Now for average, we use AVERAGEIFS because we have conditions or a condition. I got average if, and I don't ever want to use that. I'm always going to use the S versions Not only are these argument names in the screen tips easier to read and interpret, but of course, the S version of all these functions allows us one or more conditions. Average range, those are the actual numbers we want to average, so I select that column, comma, and the criteria range, that's the full column of all the majors, comma, and criteria 1, if I select just accounting, AVERAGEIFS would deliver a single answer for accounting. But if I highlight the whole spilled array, well, first, Excel knows that the formula only lives in the top cell E19, and then it uses the spilled range operator to say, hey, get everything that spills from that cell. Now, when we put multiple items into the criteria argument, it will deliver an answer for each major and spill the results. Close parentheses and enter. Now, to calculate the total average, you cannot average the averages. We're just going to use the average function, and we average all the original GPA numbers. That way, it takes the 10 values, adds them up, and divides by 10. Close parentheses and enter. Now, next, we want to see how to do it with Power Query. And in Power Query, there's a feature called grouping. And what grouping means, and actually a pivot table groups also. But the term grouping means when it makes a calculation for accounting based on GPA, what this tool and what Power Query does is goes and groups together all the records that match accounting. And then it makes the average on whatever column you specify, in this case, GPA. Now, the term grouping comes from databasing and the SQL computer language. But you'll see it's almost as easy as a pivot table. All right, we're going to click in a single cell, go up to Data, Get and Transform Data, and there it is, From Table or Range. When I click, this will bring the table into the Power Query editor. And here's how easy it is to group. You select the column where you want to create the unique list. And in the Home Ribbon tab, Transform, there's the Group By. Over in Transform Table, there's the Group By. Or you can simply right-click Group By. Basic, that means we just have one field. You can select Advanced and then do multiple conditions or criteria. We're just going to do one. Because I selected Major, the unique list will be based on the field listed here. The new name for the calculation is going to be something like average GPA. The operation, some aggregate calculation. We're going to say average. I definitely don't want to average the student. I want to average GPA. Now, the amazing thing about the Group By feature is we selected 2 columns. These are the only 2 columns that will appear in the result. So when I click OK, there's my Group By average GPA. Looks just like the pivot table or our solution created with the worksheet formulas. Now I'm going to go to Home, Close and Load 2. Let's load this as a table on the existing sheet, H18, click OK. Now this is an Excel table, so we can come down here below and type average. When I average the GPA and hit Enter, watch what happens. It actually creates what's called a total row. All Excel tables do this, and the total row will just be pushed downward as new records are added above. I'm going to type average and tab. And in fact, I like average better than total. Now, when do you use each one of these? Well, the pivot table is the easiest. I would use Power Query if we were importing this data, and this is all that we needed. And you use worksheet formulas when you're going to add new data and you want the result to update instantly. Now, I didn't leave enough room to add some new records, so I'm going to insert a few rows, selecting row header 15 and 16. Let's go to 17. Right-click, Insert. And then down below here, here's some new records. Copy. And when I paste below the table, of course, those are automatically incorporated into the table object. And both business and history are updated. Of course, with a pivot table, you have to right-click Refresh. Same with Power Query. Right-click Refresh. Now, I just noticed we forgot a step in this query. Queries are awesome because you can edit them at any time. Not only that, But I don't like that name at all because that's the name of this table. And this is not a table of that data. This is a report. So I'm going to double click this to edit, rename it, something like Major GPA Report. And we're going to add a new step coming up to the filter dropdown. And we'll sort ascending. Now we can just click close and load because it's already been loaded. And sure enough, there's our report. Now, there is one downside to this formula report right here, at least the way we built it. If one of the majors changes, before I hit Enter, remember, this is a spilled array. Everything's spilling from that top cell. But we type the word average right there. So as soon as I hit Enter, there's not enough room for it to spill all the results. So no problem. We could simply move it using my Move cursor and then apply some formatting. But Control-Z, I'm going to leave it history. We will definitely see in a future video how to deal with this problem using single cell reporting formulas. But there you go, pivot table, worksheet formula, and Power Query for making a calculation with a single logical test. Now we want to go over to the sheet and1 and talk about and logical tests. Now here's our task on this sheet. Students are eligible for a scholarship if they have completed 45 or more credits and have a GPA more than 2.5. We just want to create a worksheet logical formula that shows if they're eligible for the scholarship. That means a formula here that'll tell us true and false in each row. Now, anytime you get a statement like this, the trick is converting the language into a comparative operator. 45 or more. Well, 45 is included, and anything more than this. Notice they could have said it in a different way, at least 45. They could have said it greater than or equal to 45. In either case, 45 is the min. So whatever the credits for the student are have to be greater than or equal to. And of course, in Excel, we don't have a single symbol like we do in math for greater than or equal to. So you have to put greater than and then a second character equal to. And then the second written statement, GPA more than 2.5. Well, it can't be 2.5 because it's got to be more than. So this is a case where we don't use the equal sign. GPA greater than 2.5. Now this is the perfect job for the AND function. The AND allows us up to 255 logical tests. We just want 2. Now, one important thing about the AND function and OR and other similar logical functions, they are aggregate functions that can only deliver a single scalar result. Just like the SUM function, which takes a bunch of inputs and delivers one answer, and is the same way. It can take a bunch of inputs, but it can only deliver a single answer. What that means is we can't spill the results using the AND function. Now we can use the Boolean operator for AND in this column if we want to spill the result, or inside the filter function. But when you want a true or false for each row in a column, the AND is the easy way to go. Now we take credits as a relative cell reference. As we copy the formula down, that cell reference will move to each row. Then greater than or equal to 2 characters. There's the hurdle. And we need to lock this, so we use the F4 key. That means as we copy the formula down, it'll always be pointing to C10, locked on C10. Now that's the first logical test, comma. The second logical test, well, we need to look at GPA as a relative cell reference. Greater than, without the equal sign, there's the hurdle, 2.5, F4 to lock it. And that's our second logical test. Now we close parentheses, Control-Enter, double-click and send it down. Go to the last cell, and I want to verify with F2 whether I got the right relative cell references and locked cell references. And sure enough, 75 is greater than or equal to 45, and 3.9 is greater than 2.5. So we get a true. Now, what if we want to spill the results? Then we need to move away from the AND function and use what's called Boolean Math Operators. For an AND logical test, we can use multiplication. For an OR logical test, we can use addition. So let's see how this works. we have to do 2 tests, and we're going to have to isolate each one inside of parentheses. Now I want this to spill, so I highlight all the credits. Then I greater than or equal to the hurdle. When I close parentheses, already, as we saw earlier in the class, when we use a spilled formula, there's 2 big advantages. One is we don't have to manually copy it down, and the other is we don't have to lock a cell reference. Now let's just see if this first logical test will work when I hit Enter. Sure enough, this tells us all of the students' credits that are greater than or equal to 45. 90, we get a true. 23, we get a false. Now in the top cell, F2, for the second test, this is an AND, so we use multiplication. Then we build our second logical test of all the GPAs. Are you greater than the hurdle? Close parentheses. Now you might already guess there's a math operator. When it sees trues or falses in any part of this formula, they'll now be converted to ones and zeros. When we hit Enter, now we get zeros for false and ones for true. Now the reason that this works, F2, when we use multiplication for an AND logical test is, and I'm going to do something dangerous here. I'm going to highlight that in F9 and then do the same thing on this side, F9. What makes multiplication work as AND is we have an array of trues and falses, 2 of them, and each corresponding element will be multiplied. Well, if true is 1 and false is 0, then of course 1 times false is 0, which is false. If in the third position we get true times true, that's really 1 times 1. So when we multiply 2 trues, remember both tests must be true. But when we multiply them, we get 1, which tells us true. And it doesn't matter if there's 1 false on this side or this side. Whenever that multiplication is done, if there's 1 or more false values, it comes out 0. If we highlight all of this and hit F9, there's the result that spills. Now we got to be careful here. We use the F9 key while in edit mode more than 1 time. If you try to undo this, Control Z, it only works 1 time. So anytime you put a cell in edit mode and you mess with your formula and you want to revert back to the original formula, you use the Escape key. When I escape, it reverts back to whatever the formula was before I put it in edit mode. Now this is beautiful because we didn't have to manually copy or lock. But the real power of an array of ones and zeros is inside the filter function. Notice we have 1 and 0, a marker in essence for each student name. So what we really ultimately want in this solution is I want to be able to extract all of the student names that get a scholarship. Now I'm going to cheat, and in edit mode I'm going to copy that, escape. Over here equals filter. The array, those are the items that we want to filter. So I highlight the student names, comma, and the include argument is where we put our array of trues and falses or zeros and ones. Control V. That's exactly what we have there for include. Now if you want to put a message when the filter returns nothing, you can do that in the third argument. Close parentheses. And when I hit Enter, I get a list of the students who are eligible for this scholarship. Now, the real beauty of formulas, of course, is if I'm required to change the hurdle, all I have to do is change this, right? So now it's going to be 70 instead of 45. And when I hit Enter, now I have extracted, based on the new conditions, student names that are eligible for the scholarship. All right, we have the AND function, a spilled Boolean result, and the filter function, all using an AND logical test. Now let's go over to the sheet AND2. Now our task here is that customers are sent a thank you email if total paid is greater than 0, that's this column right here, and their account status is excellent, that's this column. Now because the logical test is greater than 0, and we're going to assume that we're never going to get negative numbers, all of the non-zero numbers are considered true. So we'll use the AND first, and for logical test, all we have to do is select the cell. Everything will be true except for 1, 2, 3, comma, and we'll take account status equal to whatever's in this cell, F4 to lock it, close parentheses, Control Enter, double click and send it down. I'll check the last cell, F2. The relative cell references and locked ones are all still pointing to the correct location. So it looks like 1, 2, 3 people get letters. Now for a Boolean, this is actually going to look funny, but we can highlight this whole column because we want it to spill, times in parentheses, arrow over, Control Shift down arrow, equal sign, Control arrow, close parentheses, and when I hit Enter, well, it looks funny in the spreadsheet, but sure enough, excellent, greater than 0, excellent, greater than 0, 3 times. Now, if you wanted to see ones and zeros, it's not too much more complicated. We just say greater than 0. Now this will spill zeros and ones. Now Control Z. The thing about this is if we're going to use this inside of the filter function, who cares what it looks like? It's shorter than having to type the comparative operator and 0. Control C, Enter. Over here, equals filter. Here's the names, comma, Control V into include. Close parentheses and Enter. There's the 3 names. Now, I bet if we had an email category, we'd extract that also. All right, now we want to go look at SUMIFS and related functions, which all, by default, do AND logical tests. Now, here are the ifs with an S functions, one that counts, adds, averages, calculates the min and max. And notice how similar the arguments are. They all can take up to 127 pairs of criteria range and criteria. Range is always all the items, and the criteria is the condition or criteria. Now notice, because SUMIFS, AVERAGEIFS, MINIFS, and MAXIFS all need numbers to do their calculation, each one of these has one extra argument above what COUNTIFS has. COUNTIFS is only counting, so all it needs is internally to have all the conditions and criteria to count. Now our goal from this small data set here is simply to make all of these aggregate calculations for the month of July, the customer Safeway, and the product bananas. So in the top cell, COUNTIFS. And by default, COUNTIFS, SUMIFS, and all these related functions do an AND logical test. It never matters which order you do it in. Let's just pick product. We'll do this one first. So I'm highlighting that. That's the range, comma, the criteria, bananas, comma. And I'll just do it in a wacky order here just to show you. Month, comma, condition. That's the second one. Criteria range 3, customer, comma, the third condition, Safeway. Now watch this. I'm going to close parentheses, and I'm going to totally cheat. Since we're doing the same set of conditions and criteria for all these aggregate calculations, I'm going to copy that Control C. But COUNTIFS will do the trick only when it finds July and Safeway and bananas will it count. Enter. Now before we use SUMIFS to add, we just copied all of the arguments, all the ranges and related criteria, 3 of them from COUNTIFS. And the reason we can just copy and then paste them into each one of these is because the arguments for each one of these functions after their first argument are exactly the same. Range criteria, range criteria. To add, we use SUMIFS. And if you forget how these arguments work, just read it. Sum range, well, that has to be all the numbers, comma. And then the rest of this, 3 criteria ranges, 3 conditions, Control V. Now I'm going to cheat even more because although we're going to do average, min, and max, all of these arguments are the same. Control C and Enter. Equals AVERAGEIFS. And this, of course, doesn't say sum range. It says average range. It still needs all the numbers, but it's going to make the average aggregate calculation. Control V and Enter. Equals min. And one interesting historical note, MINIFS and MAXIFS don't have a parallel function without the S. These came earlier in history, and by the time they got to MINIFS and MAXIFS, they realized they never need that one without the S, because everyone can just use the more convenient, more versatile one with the S. So there's only a MINIFS. It reminds you it needs a range of numbers, but it's going to make the min calculation. Control V and enter. Equals max. There's only one with the S. Control V. It's going to calculate the max from this column. And it better give me 1,461 and 60 cents. And of course, if we come up here and change our condition from July to June, our calculations update. But look at this. The yellow highlighting for the row that meets all the conditions updated also. If I change this to Whole Foods, just like that, the formulas and the conditional formatting update. Now, unfortunately, home conditional formatting, we have all these amazing built-in features, except for there's no built-in feature to conditionally highlight a row. Well, no problem. We'll build our own logical formula and add it into the dialog box for formulas. And the formulas behind the scene will deliver either a true, the formatting is applied, or false, the formatting is not applied. And that will happen in every cell. Now, instead of using the dialog box, when you're learning how to do this, it's much easier to build the formula in the cell, copy it over and down, and see if the pattern of trues and falses are correct for applying the formatting. Now, the hard part about conditional formatting for a row is the fact that we have to use mixed cell references. Now, since dynamic spilled array formulas have been around, we don't have to worry about cell references like absolute and mixed cell references very often. But conditionally formatting a row is still a place where we're always going to have to use mixed cell references. Now, because the conditional formatting dialog box will copy the formula we create from this cell over and down, we're going to build our formula from the point of view of that cell. So we'll and we have to check for all three conditions in each row. We select month that we need to match against whatever the month is here. But guess what? When we copy the formula across the columns, the B needs to be locked. But when we copy it down, it needs to move to the next month, which of course is 23. So we click, touching the cell, and hit the F4 key, not once, but twice, 3 times. Now notice if I keep hitting the F4 key, this is a merry-go-round, toggling through the different types of cell references. Relative, absolute, only the row locked, only the column locked. That's what we want. Are you equal to whatever we put in that cell? And this is locked in all directions, so F4, comma. Then we check the customer, locking the column, F4 3 times. Are you equal to whatever's in that cell? F4. Now we check product, F4 3 times. Are you equal to whatever's in that cell? F4. Close parentheses. Control Enter. And there's 4 columns, so we copied over 4 columns. And then down a bunch. And sure enough, there's the pattern. A bunch of falses. And for this row, we get all trues. We get all trues down here for these 2 rows also. Now let's check out how these mixed cell references work. If I F2, notice B22 is pointing to June. When we copy this formula over to the next column, that cell right there still needs to be looking at all 3 of these conditions. Tab F2. Sure enough, B22 is still B22. The blue one is still locked on month. And it's locked on month because there's a $sign in front of B. So here's the B column. When the formula copied over, that $sign prevented the B from turning to C. But now F2, there's B22 when I hit Enter and F2. Sure enough, we allowed B22 to move to B23 because we didn't have a $sign there. That's the power of mixed cell references. Now in the top cell, F2, and copy this formula from edit mode, Control C, escape. Very carefully, highlight. You don't want to go like this because then the active cell is down there. Because we built the formula right here from the point of view of that cell, that has to be the active cell. Conditional formatting. And I'm going to go to Manage Rules because I want to delete the one that I already have there. Delete. New rule. Use a formula to determine which cells to format. Format values where this formula is true, Control V. Format, you can use all 4 tabs, including number formatting. I'm going to select actually a different color. We'll say blue. Click OK. 3 times. Click OK. Click OK. And that is amazing. If I come up and change this to June, now it shouldn't all be yellow for a matching row, but blue. Control Z. All right, so very importantly, we have COUNTIFS that doesn't need that first argument. But SUMIFS, that needs a column with numbers. Same with these 3. And then we saw how to build logical formulas for conditionally formatting the entire row. All right, let's go over to the sheet and 3. Now our goal is to create a report to add sales from this column, by customer from this column, product, here's the column, and the specified month in this cell. And we want to do it with worksheet formulas and a standard pivot table. And we're going to create a cross-tabulated report. That means a unique list of customers down the rows, a unique list of products across the columns. Now, anytime you have a report like this, by far the easiest method is the pivot table. So let's start with that one. I'm going to click in a single cell and use the keyboard Alt-N-V-T. I want it on an existing sheet, say G17. Click OK. We can drag customer down to rows, and instantly we get a sorted unique list. Same when we drag products to columns, sales down to values, right click, number formatting, something like number, I'll show 2 decimals, click OK. I'll type a label and indicate the unit and enter. Now, since Microsoft 365 gave us all sorts of amazing functions like sort and unique, we can do it with worksheet formulas. Equals will start with sort, and then inside of sort we'll nest unique. The array, that's just the column with all the items. Close parentheses, and enter. Then for product, we'll use the same nested functions. Product, close, close. But when we hit enter, there's a problem. We really want it transposed going across the columns. So in the top cell where the dynamic spilled array formula lives, F2, we'll use the transpose function. That just takes vertical, makes it horizontal, or vice versa. Close parentheses and enter. Now we have 2 conditions at the head of the row, 2 conditions at the top of the column, and every cell needs to be for June. Well, when we're adding with conditions and we have an AND logical test, the perfect function is SUMIFS. We select for some range the sales, comma. And now we have to match up 3 times a column and a condition. It doesn't matter in which order we do it. I'll start with month. Month, that's the range 1, comma. Criteria 1, there it is. And I don't need to lock it because this formula is going to spill, comma. Criteria range 2, well, we'll go to customer. There's the customer, comma. And I don't want to put just a single item into criteria 2. I'm going to highlight both items. Now, right now, SUMIFS will deliver 2 answers, one for Safeway and Whole Foods based on June. And that's a dynamic spilled array, so it has the single cell and the spilled range operator, comma. There's product, comma, and we do the same thing for the 3rd set of criteria, that spilled range. And here's the amazing thing about Microsoft when they design these dynamic spilled arrays. If I put a vertical range and a horizontal range, it knows to match up apples with Safeway, apples with Whole Foods, and then bananas with Safeway, bananas with Whole Foods. So when I close parentheses and hit enter, the results spill. Now, just in case it expands, I'm going to highlight a few cells more. Control 1. Notice we're using format cells because this is actually in the worksheet, whereas down here we use the pivot table number formatting option. So number, 2 decimals, click OK. I'm also going to highlight and then use Control to highlight a few more, and Control B. Now, we didn't add fancy formatting or total rows, but a few videos ahead we'll see how to do it with a single cell formula. Now we have a month condition up here, but that's only controlling the worksheet formulas. It's definitely not going to control the pivot table. But let's click inside the pivot table. And instead of adding a filter here, let's go up to Pivot Table Analyze, Filter Group, and Insert Slicer. We can check month, click OK. We can move it, resize it. Now because this is a filter, when I select June, every calculation in the pivot table now has that condition, June. For this calculation right here, it has 3 conditions. Product equals bananas, customer equals Safeway, and the month equals June. Now the difference between pivot tables and worksheet formulas is simple. If I change data in the source table, worksheet formulas update instantly. And because the pivot table always takes the data and stores it behind the scenes in a pivot table cache, when data changes, we have to refresh. So if I change this last record, not Safeway, but Thriftway, watch what happens to this report and this one when I hit Enter. Instantly, this report updates. In order to get the pivot table cache to update, right-click Refresh. Now I'm going to Control Z, Z. All right, so 2 cross-tabulated reports with 3 different conditions in an AND logical test. All right, let's go over to the sheet AND 4. Now we have a data set that has data about assembly times for 12 different posts. In this column, we have the post, post 1. Then it's listed again down here, then listed again down here. In the second column is the time to assemble the product, 9 seconds, 10 seconds, 8.3. And our goal is to count how many times a post fell below the required 10 seconds assembly time. And this is an AND logical test, because we need to ask of this column, where is post 1? And then with this condition right here, using this column, is the time less than 10 seconds? And our goal is to count, so we use COUNTIFS. And by the way, we're not going to use a pivot table here because a condition like this is harder to do in a pivot table. And we would have to add an extra column that marked each row. True or false is the time less than 10. So COUNTIFS is going to be the way to go for this problem. Criteria range, well, let's do post first. Control-Shift down arrow. Control backspace to jump back to the active cell, comma. And the criteria, well, we want this to spill, so I'm going to highlight all 12 conditions. That's criteria 1, comma. Criteria range 2, Control-Shift down arrow, Control backspace, comma. And then here we have a single condition, less than 10. Close parentheses, and when I hit Enter, that spills the results. So looking at the results, it looks like post number 8 was below the required 10 seconds 48 times, but 7 was only below 17 times. Now, we could ask a different question. I want to see how many times the person was above 10 seconds, actually greater than or equal to, because we're required under 10. And when I hit Enter, sure enough, 8 was over that time limit only 1 time. 7 was 32 times. Now, you could make other calculations like AVERAGEIFS with just a single condition here and find out the average for each post. Now, we want to go over and talk about a different kind of AND logical test, a between logical test. Now, here's a small data set with date and sales. And these are 2 common reports where we have to use a lower and upper limit to make a conditional calculation. Now, this is a monthly sales report. And normally, you don't think that there's a lower and upper limit. But there is. And in fact, to get a number to be included in one of the months, you have to ask 2 questions of each date. Hey, date, are you greater than or equal to the lower limit? And are you less than or equal to the upper limit? Now, in this report, we're going to add. Over here, we'll count. So anytime you do an AND logical test and you're adding, and you want a worksheet function, SUMIFS is the function to use. Now, sum range, we are trying to add sales, comma. Criteria range 1, well, we have 2 conditions. And guess what? Both of these conditions are going to be working off the same column. So for criteria range 1, we'll highlight date, comma, and whatever date we find has to be greater than or equal to the lower limit. So the comparative operator goes in double quotes, and then we join it to the lower limit. Now, when you look at this construction here, notice the big side is pointing towards the dates. It's going to ask, hey, date, are you greater than or equal to this lower limit? Now we type a comma. And yes, we have to repeat in criteria range 2 the date column a second time, comma. And then this is the upper limit. And whatever date we find must be less than or equal to the upper limit. Now, I really want this to spill, so watch this. I'm going to double click to highlight it, redirect all of the upper limits to that comparative operator. We'll do the same thing here. Double click, redirect all the lower limits. And when we close parentheses and hit enter, there's our monthly sales report. Now, you should be asking the question, hey, wait a second. I already know how to use a pivot table, and with a few clicks, I can create a monthly sales report. Why would I ever use worksheet formulas? Well, of course, as we mentioned, if the source data is going to change and the report requires that it instantly updates, that's when you use formulas. Now, let's remind ourselves how easy it is to create a monthly report like this using a pivot table. I have a single cell selected. I'll use the keyboard Alt-NVT, existing, E18, click OK. And of course, when we drag a date down to the rows, instantly dates are grouped into various date categories. Now, I don't want date, days, and I want to rename this month and enter. Now, with a pivot table and a date column, dates are automatically grouped together in a between condition. For January, it's still using these same two dates, but it's happening internally. Not only that, but let's take a look at what the pivot table does to group. Right click, and there it is, group. This dialog box automatically selects months or years if you have years when you drag a date. But guess what? You can use this to group any particular date categories or even time categories. The hours category is particularly helpful when you have internet sales and you have a time column. Group by hours, and you could see the most sales or the most transactions by hour. Now, dates use this grouping feature automatically. In our next report, we'll have to manually use this feature. Now I'm going to click OK, drag sales down to values, right click. We'll add some number formatting. Oh, it looks like I typed month and then I went to the grouping feature and add this back. I'm going to type month, tab, and watch this. What I would really like is I just want the field name listed here. Well, if I type the field name as it exists exactly in the original data set and I hit enter, that is not allowed in a pivot table. So here's a trick we've been using ever since the pivot table was invented. You just add a space at the end. And then because there's a character there that doesn't match the original field name when I hit enter, now I have what looks like the field name at the top. All right, our next report is a common retail sales report where the people analyzing the sales for the business, they want to know how many people spend between 0 and 500, 500 and 1,000, and so on. Then they can see what sales amount is most common. Also, we have an upper limit of 500, but here in the next category, the lower limit is the exact same number. Now, over here, when we created this formula, notice we had equal signs on both greater than and less than. And that's because the upper limit of this category is not the same as the lower limit of the next category. When you have this scenario, if you include the equal sign on both comparative operators, you'll count 500 here and here. You do not want to double count. So when you get into a situation like this, yes, we could put 499. But one of the conventions when you have decimals is to not do that. If this is the case, then you have to choose which side gets the equal sign. Now we're going to choose greater than 0 and less than or equal to 500. The equal sign is here, so the 500 will be counted here. But down here, since it's the lower limit, we're going to say whatever's over there has to be greater than 500. So 500 will not be counted here. Now, a formula like this, we'll use COUNTIFS. But a formula like this is very important because when we look at the pivot table in just a second, when the data has decimals, the grouping feature does not include the upper limit in the count. So if your report requires that the upper limit is included, you cannot use a pivot table. All right, let's see how this works. Equals COUNTIFS. And we're actually going to count twice. Each number has to be compared to the lower and upper limit. So for criteria range, we'll highlight sales once, comma. The lower limit does not have an equal sign. And guess what? You get to choose, but just don't put it on both sides. We're going to highlight all the lower limits, comma. Repeat the sales column. 2 questions are being asked of that sales column. This is the upper limit. So whatever we find has to be less than or equal to whatever the upper limit is. Shift arrow down. And so now when I hit Enter, there's the count. Well, it looks like most people are spending between $500 and $1,000. And it looks like almost everyone spends $1,500 or less. Also notice that that 500 is counted in this category. Now let's see how to do it with a pivot table. Click in a single cell, Alt-NVT. We're going to select Existing, J18, click OK. And we're not going to drag date. We're actually going to drag the sales category to rows. And of course, you can guess what's going to happen. It's not going to automatically group, but anything dropped into rows instantly gives you a unique list. And we need to group this and tell the grouping category, please go from 0 to 500. So you right-click somewhere in the rows area, Group. And this is so polite. It knows it's a number, so it shows you the min and the max. So we're going to change this to 0. And whatever we change it to, it has to be equal to the min or less. And whatever we change this to has to be equal to the max or above. So I'm going to put 2,000. The reason I'm putting 0 to 2,000 is because I want nice, neat categories. And we'll say 500. Now when I click OK, that is beautiful. Now when we drag sales down to values, remember this is a number field. Usually it defaults to the sum function. But because there's a group category here, it defaults to count. Sometimes you do want to add, so then you'd right-click, Summarize Values By, and change the aggregate calculation. But that's exactly what we want. I'm going to change this to count, Enter. And notice 0 to 500, 500 is not included there, so we get a count of 5. Up here, 500 is definitely included, so we get a count of 6. Now there is one ambiguity with what the pivot table does. It says 0 to 500. And then 500 to 1,000. A lot of people get tricked by this, and they're not sure which category gets the 500 or does both get the 500. But the rule is always the same. Whatever you put in as the upper limit, it is not included. Now, we can either change the label up here or these categories to make it less ambiguous. Now, up here I said lower limit not included. That's one way. We could say something like upper limit not included, and then go to Home, Wrap Text. Here's another trick. In statistics, it's common to indicate that the upper limit is not included by creating a category that says 0 up to 500, 500 up to 1,000. Now, I don't want to type this here, so I'm going to highlight everything, and I'm going to use the Replace feature. Now, Replace is Home. I hardly even know where it is because I always use the keyboard, but there it is. Now notice the keyboard, Control-H. I'm going to use Control-H. I do a lot of replacing, not only in Excel, but also in Word. Control-H, find, replace. Find what? A dash. Replace with, I'm going to type a space, up to, and a space. When I click Replace All, because I have this pre-highlighted, it'll replace all 4, replace all with up to. Click OK, click Close. You don't have to have both. You can choose which one to do. And if you're using this for your own analysis, Just knowing that the upper limit is not included is enough. All right, so between is used all the time in many scenarios, from monthly sales reports to what is called a frequency distribution to tell you the counts across some number category. All right, let's go to the sheet OR 1. Now we have a great example here to start off our study of the OR logical test. And remember, anytime you have an OR logical test, you got to ask the question, am I running this test over one column or two columns? To illustrate this, we'll do a scholarship example. There are two different rules for issuing a scholarship. Here's the first rule. Students are eligible for the scholarship if their major is history or sociology. Here's the two conditions. And guess what? Those two conditions are working on a single column. That means the only two answers to this OR logical test are we got 0 truths or 1 true. And that's because for any particular major, that major can never simultaneously be history and sociology. And we'll see this result when we build our formula to spill, or when we build an average formula or a filter formula. Rule number 2, students are eligible for a scholarship if their major is history or they have credits 60 or more. Here's the two conditions, and they're working over two different columns. That means the possibilities are we got 0 truths. We could get 1 true from either this column or this one, and we can also get 2 truths. Now, those numbers will also show up when we spill our results, do an aggregate calculation, or use the filter function. Now, let's start off by just marking each row with a true or false, and then we'll spill the two different rules. Equals OR. The arguments are the same as the AND function. We can put up to 255 logical tests. I'm going to ask the question, hey, business, as a relative cell reference, are you equal to history, F4 to lock it? That's logical 1, comma, logical 2. The exact same major, are you equal to sociology? F4 to lock it. Close parentheses, Control Enter, double click and send it down. I think that's a glitch. If I scroll up and scroll down, it goes away. And it looks like we have two students that qualify for rule number 1 scholarship. History, true, but sociology, false. Comparing this to history, false, but comparing this to sociology, true. Now, if we want to spill this, equals, open parentheses, we highlight all the items from the major column, and we want to ask the question, are any of you equal to history? Now, we close parentheses, and whereas multiplication is used for an AND logical test, when we do an OR logical test, we use addition. So we use plus. Open parentheses, same column, equals, and we're going to ask a different question. Are you equal to sociology? Don't need to lock it. Close parentheses. And when I spill, I get 0s and 1s. We got a 1 in this row because history is matched here, but history in the OR logical test did not get a true for sociology. Down here, no match for major, but we got a match with sociology. So 2 1s. Now let's do the same Boolean math construction, but we're going to do the second rule and work across two columns. Equals, open parentheses. We got to ask, hey, all the majors, are you equal to history? Close parentheses. This is OR, so we use plus. Now we're asking of a second column, hey, credit column, which ones are greater than or equal to, and it says 60 or more, so the 60 is included. We click on our credits, don't have to lock it, close parentheses. And now when we spill, the possibilities are 0, 1, and 2. For this student right here, credits got a true, accounting got a false. But down here, history got a true, 70 also got a true. So true plus true equals 2, which is a true. Now F2 at the top, just as we did with the AND logical test. If we highlight this little bit and F9, we get an array of trues and falses, plus F9, another same-sized array of trues and falses. If we look in the fourth to last position, there's a true. But look at over in this one when it adds this true, since true is converted to 1 with this math operator. 1 plus 1, that's how we get the 2. Now I'm going to click Escape. Now our next task is to calculate the average and show the actual student names for rule number 2. And I'm going to cheat F2. We're going to use this exact string of 1s, 2s, and 0s in both of our formulas. So Control-C, Enter. Now, if we're doing an OR logical test, we cannot use the AVERAGEIFS function. AVERAGEIFS is programmed by default to do an AND logical test. So we're going to have to do something different. Escape equals average. But how in the world am I going to get just the numbers I want? There's a true, so that 2.3. There's a 2, so that number. How are we going to get those numbers into average? Well, this is a conditional calculation, so we can use the if function. All we have to do in if is put this array of trues and falses into logical test. And then into value if true, we put the GPA numbers. And if will pick out the right numbers. Control-V. So that's the logical test, comma. Value if true. I'm trying to get just some of these based on this OR logical test. And here's the amazing thing about the if function and the average. If I leave value if false out, meaning I don't put anything into this argument, the if function will insert a false into the resultant array anytime it sees a 0. And lucky for us, the average function and all aggregate functions are programmed to ignore logical values like a false. So I'm simply going to close parentheses on if. That whole if is what we're using to pick out the right GPA numbers to dump them in average. Now, before we look at this and evaluate it, let's close parentheses, Control-Enter. So there it is. For the people who are eligible for the scholarship by Rule 2, the average GPA is 3.36. Now, F2, let's see how this little magic if function works. We already know in logical test, if I F9, those are trues and falses. The if will see this false value, so it's not going to get that 1.7. Here it's going to see a true, so it will pick out 2.3. If we evaluate this part, this is just that column. 0 will say, hey, don't take that one. 1 will say, take that 2.3. And if we highlight the whole if and evaluate it with the F9 key, that is some if function magic to get just the numbers we want from the GPA column based on an OR logical test. That false will be totally ignored by average, but the numbers will be added and then divided by the count. Now I'm going to click Escape. For filter, we'll use the filter function. The array, those are the items we want to filter, all the names, comma. Include, I Control-V. Those trues and falses will pick out just the names we want. So close parentheses and Enter. Now for rule number 2, if I change the hurdle for credits to 100, when I enter this, everything updates. Control-Z. So for the OR logical test, when you need a row by row true or false, the OR function is perfect. When you're dealing with just one column and an OR logical test, the only possible values are 0 and 1. If there's 2 columns, 0, 1, and 2. By the way, if there's 3 columns or 4 columns, then you'll get for 4 columns 1, 2, 3, or 4, or 0. Also notice, when you're doing Boolean math OR, put whatever the logical tests are in parentheses and put a plus between them. If there were more OR logical tests, you just put more pluses. Really, it's the same thing here. There's just a slightly different test inside of each set of parentheses. All right, now we want to go over to the sheet OR2. Now on this sheet, we want to do 3 different things. Here's a sales team. I do want to add all the sales from this column based on the sales team matching up with this column. I want to add a true, false to each row. And I want to show you how to add conditional formatting to the row when the sales rep is on sales team 1. Now for all 3 tasks, adding a true and false, and adding conditional formatting, This is an OR logical test where we have 4 items and we're checking them against one column. Now you definitely can use F2, the OR function. We're just checking the same cell against every one of the teammates. And that, of course, will work. However, anytime you're doing an OR logical test with 2 or more items, there's an easier way to do it. And really, if you think about this, you're trying to compare the sales rep from this list and find out if they're over in the team list. And the perfect function for checking whether an item is in a list is the XMATCH function. Now, the XMATCH function is a lookup function that is designed to look up a particular value and tell you the position it is in the list. So XMATCH would take Sue and go 1, 2, 3. It's in the 3rd position. When it looks up Gigi, it's going to say, I found it in the 1st position. So in the lookup value argument, we're going to do a function argument array operation and ask the question for every single row, are you over in this list? So we comma, and the list that we're trying to look up the items and find the position, there it is. Now, XMatch by default does exact match lookup. That means it's going to try to find SIOUX in this list, SIOUX. So we don't have to put any of the other arguments. Just close parentheses, and when I hit Enter, it spills the results. And sure enough, Sue is in the 3rd position. Gigi, the 1st position. But Abdi, when a lookup function can't find an item, it's polite. It says not available. Now, look at the pattern in this column. It is the fact that a number is saying, I found the sales rep over in the team list. The NA says I didn't find it. Well, guess what? This is the perfect use, F2, for isNumber. So isNumber, when it sees a number, it reports true. Anything else, whether NA, text, a logical value, it will report false. So there you go. That's the formula to use when you're doing an OR logical test with many items. When I hit Enter, the trues mean, hey, I found the sales rep in the team list. False means I didn't find it. Now, when you're doing an OR logical test, there's a bunch of ways you could do it. This is a way I wouldn't use, but it works. I just did one SUMIFS for each condition. You could also do a pivot table. And notice the only thing that we dragged and dropped was sales into the value. So we only get a single answer. Then we add a slicer. And of course, because a slicer is working on a single column, that's an OR logical test. The way that I like to solve this is by kind of tricking SUMIFS. Well, it's supposed to do an AND logical test, but watch this. I'm going to highlight all the sales, comma, criteria range. Because the OR logical test is on a single column, I'm allowed to put this into criteria range 1. And when I comma, I can just do a function argument array operation. If I say 1, 2, 3, 4 different items, that means SUMIFS will spit out a total for each item. Now, if I close parentheses and hit Enter, it spills the results. But what do I want? I really want to add each one of the sales rep sales. So in the top cell, F2, I simply wrap sum around it. And when we close parentheses, Control Enter, we get the same answer as these other 2 examples, F2. But this one's much easier. Now, when we do a function argument array operation using an OR logical test on a single column, we can use some of the other aggregate ifs functions also. If we scroll over, if we wanted to know the total count of transactions for the whole team, well, we do a function argument array operation. It counts how many transactions for each sales rep, and then sum adds to get a total of 15. If you wanted to know what the max sales amount was for this team, well, this function argument array operation finds the max sale from that data set for each sales rep. And then, of course, the max finds the max for the team. MINIFS works the same way and delivers the minimum sale amongst all the different sales rep on team 1. Now, another way we could do this, if you already made this formula, notice that's giving us a bunch of trues and falses. I could just use the sum function and say, I want you to add all of them, but wait a second. I'm going to multiply every number in that column times trues and falses. Only the true times the number will give us the number. So this formula will give us the same answer. I still like this one the best. Now, to conditionally format a row, we're going to have to use mixed cell references. And we're definitely going to use XMATCH. And for the lookup value in the first row, I want the sales rep. But every cell in this row must be locked on the sales rep in the C column. So I hit the F4 key 1, 2, 3 times. Then I comma. Here's the range that I'm looking it up. Going to look up Sue in there. F4 because I have to lock it in all directions. Close parentheses. Control Enter. Well, there's the 3s. Those are all true. Copy it down. All the numbers are true. But wait a second. NA. Up here we used isNumber. But that's because we wanted the result in the spreadsheet. The amazing thing about conditional formatting, and we'll use new rule to get to our dialog box, is of course it'll interpret any non-zero number as true. But anything else, whether 0, text, NA, error, they're all false. So very carefully from the upper left corner, remember I built this formula from the point of view of that cell. Copy, Enter, highlight all the rows, making sure that the active cell is in the upper left corner. Conditional formatting. Last time we used manage rules because we had a rule there we needed to delete. But if you're just creating a rule, this is a better option. New rule. Then we select Use Formula to determine which cells to format. Format values where this formula is true. Control V. Format. Format it as you'd like. I'm going to add yellow. Click OK. Click OK. And that is beautiful. All right, very importantly, we saw that when you have a bunch of OR logical tests, it's better to use XMatch and compare lists. If it's in the spreadsheet, you use isNumber. If you're using conditional formatting, you can just use the XMatch. And if we're adding, that's the method I like. All right, now let's go to the sheet Not and Contains. Now here's the product column, and I want to, in this column, mark each row when the product is not apples. So I say equal sign. I'm going to highlight the entire column. And of every single product, I'm going to use the comparative operator for not. Less than, greater than, and then select the condition. When I hit Enter, I spill the results. In the last row, bananas are definitely not apples. Now we could use the not function. The not function converts a true to false and a false to true. So if you do this, you have to put, are you equal to apples? Of course, that comes out true, but not switches it to false. If we're going to count, there's the comparative operator for not. I put the comparative operator and product in the cell. Notice it's aligned to the left, so it's text, which is what COUNTIFS and SUMIFS need. Criteria range, there it is, comma, criteria, comparative operator, and product. And so when I enter, I get a count of 11. Now here, I did a text formula, and I'm using this formula input, apples. So I can't put the comparative operator in the cell. No problem. COUNTIFS. And for the criteria, instead of selecting the cell, I put the comparative operator in double quotes, so it's text, join it to that product name. Close parentheses, and when I hit Enter, I better get 11. So those are various ways to do not. Now we want to talk about a contains logical test. We want to look through the customer column and ask the question, which one contain the word way? Over here, Whole Foods doesn't. Safeway does. Foodtown doesn't, but Thriftway does. Now when we're counting, we're going to use COUNTIFS and wildcards. When we're extracting records, we're going to use the search function. Now if we use COUNTIFS, looking at customer, comma, and ask the question way, well, really that's asking which one of these cells contain just way. And of course, the answer is 0. The way we get a contains into COUNTIFS and SUMIFS is we use wildcards. If I use an asterisk, that stands for 0 or more characters. So right now, it would find the word way 0 characters before, 1 character before, 2, and so on. If I put one at the end, it's going to do the same thing at the end. Those wildcards and that text will find any text that contains way. And sure enough, we get a count of 11. Now down here, we're going to have to use the search function. And I need way, not asterisk, way asterisk. So we're going to get rid of this. And of course, we're allowed to put those wildcards right into the formula. But just as with comparative operators, you got to put them in double quotes and join it. Join asterisk. If you were to highlight this and hit the F9 key to evaluate, the double quotes mean text, and then the asterisk and way, that's the contains condition. Control Z and enter. Now we can use way down here in the search function. Now we saw search back in the text video. I want to find the text way, comma, within. Well, I want an answer for every single row. Now what search does is it counts on its fingers. It can't find it here, so it gives us an error. Here it goes 1, 2, 3, 4, 5. So it's going to report 5 because it found it in the 5th position. Close parentheses and enter. This is the same size as the customer names. Numbers tell us the row we want. So of course we use isNumber. Close parentheses. And when I hit enter, I have a column of trues and falses that we can use inside filter to get at all the records. F2, the entire table, comma, include, close parentheses, and enter. If I say safe, and notice, as we said at the beginning of the video, in the Excel worksheet and DAX, the formulas are not case sensitive. Safe will equate to capital SAFE. So when I hit enter, I extract 7 and get a count of 7. Control Z. All right, so a not logical test and a contains logical test. Now let's go over to the sheet if. Now we've actually used the if function a lot in this class, but this is the first time I'll formally define it. If function is a logical function, but rather than delivering true or false, it can deliver one of two things: numbers, text, formulas, ranges, and much more. You give it a logical test, and then you got to tell it what you want to put in the cell if it's true and what to put in if it's false. Now our first example, contract reads, if an employee has sales of $20,000 or more, they get a bonus of $750. Here we're going to use the if to deliver one of two numbers, $750 or 0. So Ty Jones wants to know, using the if function, are his sales greater than or equal to, because it says 20,000 or more, there's the logical test. This delivers just a single true or false, comma, if it comes out true, 750, comma, if it comes out false, 0, and enter. Well, if Ty's sales were actually 19,999 and 99 pennies, well, the number formatting would be tricking him because that number is not greater than 20,000. And of course, he gets a bonus of 0. The boss says, oh, you know, even if you don't make your hurdle, I'm going to give you $100. Control Z, Z. Here we use the if to put one of two numbers. Now let's use the if to deliver one of two text items. The contract reads, if data is under 1 GB per month, you do not pay extra. And the text we want, if it's less than a gigabyte, we want under. Otherwise, a gigabyte or more, we want over. So the if function, the logical test, is this less than 1 GB. If that's true, under. Otherwise, over. Close parentheses and Control Enter. And so Dino is under this month. But next month, he goes crazy with his data. 2 GB. So that is over. Control Z. Now, in both of these examples, numbers and text, we only put one of two items. If we go back and look at the average calculation where we use the if function for an or logical test, if we look inside the logical test and I hit F9, that's an array of trues and falses. But the if function still delivers only one of two things. Right here for the 0, it delivers a false. When it sees 1, then it can deliver the number. So in this case, The if is delivering F9, lots of answers, but for each individual logical test, it's only delivering one of two things, in this case false or a number from the column. Escape. Now let's go to the sheet if and is. Now we have a checkbook register with date, ID, description, and the change, either a subtraction as a negative or an addition as a positive. What I want in this column is a formula that will calculate the checkbook balance. But when it gets down to a row where a date has not been entered, I want to show nothing. So in every cell, I want one of two things. I either want the formula, or down here I want double quote, which is the formula syntax to show nothing. Now the logical test is going to be built on whether or not a date is entered. And because a date is a number, we can use the is number as the logical test. Equals if is number. We're looking at a relative cell reference. That's going to come out true or false, comma. If it's true, I need the balance. And the balance formula is always going to be whatever the balance is from the previous row as a relative cell reference, plus whatever the amount here is. That's the value if true, comma. The value if false is the syntax for a formula to show nothing. Double quote, a zero length text string. Control Enter. Copy it down. If we come over and enter a date, bam, our formula shows up. Control Z. Now, we chose to use is number on a date. That means we get a true when there's a number. We could have used is blank. Notice the logic here. Down here, we get trues. Up here, we get falses. So for value if true, we had to use double quote. Value if false is the formula. We also could have chosen a different column. If we know that we're always going to put text here, then we could use is text. Now let's go over to the sheet ifs. Now we have a net income statement here where we have our revenues or sales, our expenses. There's total expenses, and we subtract the two. And in an income statement, even when you have a loss, you show a positive and indicate that it's a loss by putting the text net loss. That ABS means absolute value. It means whether this is positive or negative, it will always show as positive. So our goal is to put the text net loss, break even, that's when sales or revenue are exactly equal to total expenses, or net income. Now, this is how we used to do it. We would just nest multiple if functions. And I actually like that one better than this new function. But some people like this, so I'm going to show you. There's an ifs with an S. And it just allows you to put logical test what you want. Logical test what you want. Well, we'll start with net loss. That's when total expenses are greater than your sales or revenue. If that's true, what do we want? And this is never going to change, so we're just going to type the labels into the formula. Net loss, comma, the next test. Well, sometimes revenues are exactly equal to total expenses, comma. And the phrase for that is break even, comma. The next logical test, well, there is only one possibility. And the way this function works is it starts at the beginning. If it gets a false, it goes to the next one. Gets a false, it goes to the next one. So since this is the last one, all you have to do is put true. That's the logical test. So if it gets to this one, it knows, comma, just to put net income. Close parentheses and enter. Both of these formulas will work. Revenue is greater than expenses, so we get net income. 54,950, I better get break even. $4, oh my heavens, what a horrible loss. But our formula is working. Control Z, Z. All right, that's how to use ifs to put one of three things into a cell. Next, we want to go over to the sheet PQ, and we want to use Power Query with a complex logical test to extract records from a CSV file. Now, your boss asks you to get Seattle 911 call records with the classification type medic response or aid response for the street 904 7th Ave. Now, this is a complex test, because really this is medic response and 904 7th Ave, or aid response and 904 7th Ave. Now the file we're going to import can be downloaded below the video or at our class website. We want to go to Data, Get and Transform, From Text CSV. You want to navigate to your class folder, and there's the file. I'm going to double click. Because it's a CSV file, it guessed right, a comma delimiter. Let's click Transform Data. All right, the first thing we'll do is rename this. I'll call it 904 7th Ave Query. These steps are fine. We want to go to the Type column, and we want to build a filter. That's how we're going to extract the records. Now, when we use the drop-down, this is a unique list, and we're acting on a single column. Now, when you get big data, you want to be sure and click this blue Load More button. When you do that, it reloads so the unique list is complete. Now, we're going to search for response. Then we can uncheck everything. Aid response is one item we want from this single column, and medic response. When I click OK, it writes the formula for us. Table.select rows, acting on the previous step. And look at this. For each row, there's the type column. Type equals aid response, or type equals medic response. And notice the OR operator in Power Query is lowercase. There's an and a not also. Now we want to jump over to the address, and as soon as we go to a second column, we're running an and logical test. I click the drop down, load more. We'll search for 904. And sure enough, I'll uncheck everything and check the one we want. Click OK. And up in the formula bar, it wrote the complex logical test for us. Notice in parentheses to isolate the or first, aid response or medic response, and then it has a lowercase and lists the condition on that column. So with just a few clicks, we have our one step for our complex logical test to extract records. Close and load to table, existing sheet. We'll put it in B5, click OK. And now our boss is happy. We've extracted the records using a complex logical test using OR and AND. All right, our last example is going to be on the sheet complex. Now here's a common example from businesses all around the world that extend credit to customers. This would be in the accounting Accounts Receivable Department. We have some customers and some data about the customers. And we need to determine, based on these conditions, whether or not to extend credit. Now, here's the rule for extending credit, and it is a complex logical test. Sales last year have to be greater than 250, and the asset value has to be greater than 300K, and the late payments have to be less than 2, and at least one of the credit hurdles have to be exceeded. That means one of these two columns. Now notice when you see at least one, that indicates an OR logical test, because at least one means it could be 1 or it could be 2, or it could be 0. In addition, this OR logical test comes after an AND. So really there's 1, 2, 3, 4 different AND logical tests. It's just that the last AND logical test, that's an OR. Now let's see how to do this with the scalar functions and an OR. I'm going to look at sales last year, and this says greater than. It actually has the symbol, so it's greater than 250 F4, comma, logical 2, asset value, same thing, greater than the hurdle, F4, comma, logical 3. We're looking at late payments. It says less than the hurdle, F4, comma, and here it is, logical 4. And right inside here, we're going to put an OR. Remember, what does the OR do? It just delivers a true. And because it's sitting in logical 4, if it comes out true and the other 3 also come out true, then AND will deliver a true. So we get one or the other here, credit rating 1. And notice it says exceeds. That definitely means greater than. It can't be exactly 3. F4. And then inside of or, comma, we got to check the second one. Is that greater than this hurdle, F4? Now, when I close on or, it's sitting right in and. And that's our formula. Control-Enter, double-click, and send it down. So it looks like we have 2 customers. Now, if we're going to spill this, it'll actually sort of look like that Power Query formula we saw. Equals, and we have 4 logical tests. So guess what? We're going to have 4 sets of parentheses with a multiplication symbol between it. So all last year, are you greater than the hurdle? I love it. I don't have to lock it. Close parentheses. Times, which means and, open parentheses, asset value, greater than the hurdle, close parentheses, and number of late payments. You have to have less than the hurdle of 2. So that means 1 or 0. Close parentheses, times. And then in parentheses, we have to build the OR logical test. But remember, OR uses a plus. So we're going to have to use 2 parentheses. Build the first OR plus, the second OR, and then close it off. That way, the OR will happen before the AND. All right, so we look at here. And whatever we find there must exceed 3, close parentheses. OR is addition. Credit rating, greater than this hurdle. Now, I'm going to close. The plus can do its work inside these parentheses. And there it is, 1, 2, 3, 4 ands, with the last one being an OR. And when I hit Enter, it spills the results. Now, sometimes people want words, not zeros and ones or falses and true. So I'm going to take this whole thing, Control-C, Enter, equals if. The logical test is complex, but I already did it, so Control-V, comma. If all of those come out true, the value, if true, credit, or whatever you want to type. Otherwise, value, if false, is no credit. Close parentheses. And when I spill this, sure enough, there's 2 credits. Now, I bet you what we really want to do is extract these names. So, of course, the amazing filter. We put the values we want to filter into array, comma, include, Control-V. And here, comma, if empty, something like no customers. Close parentheses and Enter. Sure enough, Sharks Logistics and Foggy Camel Vacations, they get extended credit. All right, so that was a little fun with complex logical tests, mixing and or, scalar, spilled, if, and of course, our favorite filter. All right, that's the last example here, but that's not all. There are 9 amazing homework problems for you to practice. Now, in this video, we talked a lot about the concepts behind logical tests. And then we went through many examples looking at single condition logical tests, and logical tests, between, or, not, the if, the is, and the ifs function. We did a Power Query example, and we ended it with an amazing accounts receivable complex logical test. All right, if you like that video, be sure to click that thumbs up, leave a comment, and subscribe, because there's always lots more videos to come from XLSFun. Hey, we'll see you next MECS video.